Okay, so in this video we're talking all about perpendicular bisectors and how they relate to triangles. So you might have seen this before, but honestly I would be kind of surprised if you had. So most likely this is going to be new information. So we already know what a perpendicular bisector is. It's perpendicular to any segment or line, and it cuts it into two equal parts. So a perpendicular bisector of a triangle is a line, ray, or segment that is perpendicular to the side of the triangle at the midpoint of the side, and that's what we see here in this picture. Since this perpendicular bisector goes to the midpoint of this side, then it cuts the side into two equal parts, and again it's perpendicular, so where it cuts, it makes a 90-degree angle. And obviously, since we have three sides in any triangle, we always are going to have three perpendicular bisectors for that triangle. So, and then if we actually drew all the perpendicular bisectors of a triangle, then those lines are actually going to meet up in one particular point, and that's called the point of concurrency. So these lines are concurrent lines. So with the concurrent point of concurrency for a perpendicular bisector of a triangle, that point of concurrency can be on three different places depending on what type of triangle you have. For instance, if you have an acute triangle, then the perpendicular bisectors of that triangle will always meet up on the inside if it's acute. If you have a right triangle, then the perpendicular bisectors are always going to be concurrent on the edge of a triangle, like we see here in this picture. That's only for right triangles. And then if you have an obtuse triangle, the perpendicular bisectors of a triangle are always going to be on the outside of the triangle, only if it's obtuse though. And the point of concurrency of the perpendicular bisectors of a triangle is called the circumcenter. So when we're talking about circumcenter, we're talking about perpendicular bisectors. And the perpendicular bisectors of a triangle intersect at a point that's equidistant from the vertices of the triangle. So what that means is here, PA is congruent to BC, or PA is congruent to PB, which is congruent to PC. Those three segments are all the same length because it's this point P is the circumcenter of the triangle. And I just drew it inside a circle. I mean, sometimes you're going to see that, but that really what you have is called the circumcenter of this triangle because it's perpendicular bisectors. So it's going to be equidistant from each angle. And that's it. I'm talking about perpendicular bisectors of a triangle. Kind of messy pictures, so you might want to watch this video a couple of times. If you got questions, please let me know.